Okay, so let's have a look at another question from the 2022 HSC Advanced Maths paper. This is question 29. So we're told the diagram shows the graph of y equals 2 to the minus x. Also shown on the diagram are the first 5 an infinite number of rectangular strips of width 1 unit and height evaluated from y equals 2 to the minus x for non-negative integer values of x. For example, the second rectangle shown has width 1 and height a half. So you can see from the diagram these are height 1, height half, height quarter, height eighth, and so on. The sum of the areas of the rectangles form a geometric series. Show that the limiting sum of this series is 2. Okay. So if we look at these, they are 1 plus 1 half plus 1 quarter plus 1 eighth and so on. This is the geometric series and it keeps going on infinitely. This has first term equal to 1. It has a ratio, a product of 1 half. So we're multiplying by a half each time. And this one is actually an infinite sum. So it has infinitely many terms. So the sum of infinite terms in this type of geometric progression is the first term divided by 1 minus the multiplication value. So this is 1 over 1 minus 1 half. This is 1 over a half. This is 2. So therefore, the limiting sum, the sum of infinitely many terms here, is 2. So this is how we do this. This could have also been done geometrically, by the way. So you could have just drawn a rectangle, or let's say you could have drawn a rectangle or a square that had area 1, and then a rectangle which had area half, and then a square of area quarter, then a rectangle of area 8, and then a square of area 16th, and so on. And you can see as we continue this pattern onwards, it's going to fill up the space of 2 squares, 2 units. So this is a geometric way of interpreting this kind of limiting sum. So these can be done arithmetically, it can be done using formulas, or it can be done geometrically. The question did tell us to show the limiting sum is 2, so it's better to use the summation formula in this case. So this is part A to question 29. Part B says show that the integral from 0 to 4 of 2 to the minus x dx is equal to 15 over 16 times the natural log of 2. So this is an unusual integral. The integral of a to the x dx is known to be a to the x times 1 over the natural log of a plus a constant. So this is a known formula. This is a known integral. There is a integral form on the formula sheet very, very similar to this. So we're going to use this. So we have 2 to the minus x. Well, this will become 2 to the minus x times minus 1 on natural log of 2. So we get 2 to the minus x times the negative of that divided by the natural log of 2 from 0 to 4. So at 4, this is minus 2 to the minus 4 over the natural log of 2. At 0, this is minus 2 to the 0 over the natural log of 2. So we have minus 2 to the minus 4 over natural log of 2 minus 2 to the 0 over the natural log of 2. So we want to be very careful with this because there's a lot of negatives floating around. So we'll take 1 on the natural log of 2 out the front, and this will leave us with minus 2 to the minus 4 plus 1. So this is what we get in the brackets. Now, if we want to simplify this, minus 2 to the minus 4, well, this is 1 over the natural log of 2. And then we have minus 2 to the minus 4. Well, this is minus 1 over 2 to the 4 plus 1. So this gives us 1 on the natural log of 2 minus 1 on 2 to the 4. Well, 2 to the 4 is 16. So this is minus 1 on 16 plus 1. 1 is 16 on 16. So this is 16 on 16. 16 minus 1 is 15. So this is 1 on the natural log of 2 multiplied by 15 on 16, which is 15 over 16 times the natural log of 2. And this is the answer that we're required to show. So we used this specific form of integration, this specific integral, in order to do this, and then you just had to carefully evaluate it. Now this question has a third part. The third part of the question, part C, we are told use parts A and B to show that e to the 15 is less than 2 to the 32. Okay, so we've just done the integral of this function from 0 to 4, and we know that that has to be less than 2 because we know the infinite sum of the rectangles is 2, and we know that that infinite sum has to be bigger than the integral under this exponential. So we have 15 over 16 times the natural log of 2 must be less than 2. This is something that we have discovered through the course of the question. If we multiply both sides by 16 times the natural log of 2, 16 times the natural log of 2, this gives us 15 is less than 32 times the natural log of 2. And remember, we are after e to the 15 is less than 2 to the 32. Well, if we put both of these under an e, we get e to the 15 is less than e to the 32 times the natural log of 2. E to the 15 just stays as is. E to the 15 is less than. This, we can use our index laws. So this will become e to the ln of 2 all to the 32. E to the ln of 2 is 2. This is 2 to the 32. So therefore, e to the 15 must be less than 2 to the 32. So we used the fact that we're able to find the integral, we used the fact that we're able to find the limiting sum, we put them into an inequality, we then manipulated that inequality from its initial form, this form here, and got it into the form that the question requested. You'll notice that this question tells you very specifically to use A and B. It's possible that you could do this other ways, but if you don't use A and B, it's likely going to be much more difficult. Right? So using A and B here worked very nicely, and it got us this answer with relatively little work. So let's talk about marking. Part A is worth 1 mark. You have to be able to show that the limiting sum is 2. So using some acceptable method, most likely the sum method here is going to be most suitable, but some method in order to get this. For part B, we have to get a mark, you need to substitute correctly into the antiderivative. So calculate the antiderivative, start plugging values into it. To get the second mark, you must be able to simplify that down to get the exact solution. And then for part C, you will get 1 mark for setting up an inequality. So identifying that this is true from parts A and B. And then you'll get a second mark for provision of the correct solution. So the marking is a little strict on this question. It's not a hugely difficult question if you do the things right. The algebra is just a little bit messy. Right? So when you're simplifying these expressions, when you're doing this integral, when you're setting up this sum, you have to be really careful not to make any mistakes. Any small mistakes here will send the whole question completely wrong because it's full of weird numbers, right? 2 to the 32, e to the 15, natural log of 2 times 15. Like, these are very unusual numbers. The minute one of them goes wrong, the whole question no longer works, right? So if you have 14 on 16 times natural log of 2, everything else falls apart. You cannot possibly get the answer from that. So you have to be very cautious with your working. These kind of questions, you want to work slowly.